Okay, so here we go, part 4, the last video in our series. This one is additional topics. So basically, it just covers everything that we haven't talked about yet. Okay, now a lot of this section will deal with circles, triangles, basically geometry, okay, and finding the volume, area, or anything like that about these shapes. So they give you, at the beginning of each section, they give you a big formula chart. Okay, so just recognizing when you have a circle or a triangle, or they're asking you for the volume or area of something, unless you know it right off the jump, right off the bat, just cycle back to the first page and you'll have all these formulas. Okay, so we should be familiar with a few of them already, okay, but just in case, it's always here as a reference for you. Okay, so first, kind of an unrelated topic actually, but something that we have to know are complex numbers. Okay, so what they are is the number I, okay, is defined to be the solution to the equation x squared equals -1. Okay, so the number I stands for imaginary. So I squared is -1 because typically when we square a number, it's always a positive number. Okay, but in this case, I represents this imaginary number. Okay, the square root of -1. If we were to type this into our calculator, okay, we would get an error message. Okay, and complex numbers, this is a kind of our way around that. Okay, so they're in the form of a plus bi. Okay, so a is just any old number. Okay, b is also just a number. Okay, but then we follow it by I. Okay, so this is the standard form of a complex number. Okay, so just a note here. Okay, if we were to take I cubed, we could separate it into I squared times I. Okay, we know I squared equals -1. And we're still left with this I. Okay, so we would write it as -I. Okay, whenever we have something like I to the 5 or something like that, we always want to reduce it. Okay, where we're just left with either just an I by itself or a -I, or we'll reduce it to a positive or -1. Okay, and you'll see some of those examples come up. But here we have I to the 4, which we can break up into I squared times I squared, which is just substituting in -1 times -1, which is +1. Okay, so real quick, we'll do some quick examples here. Okay, when we're adding or subtracting complex numbers, okay, it's just like collecting like terms, where you're going to add your numbers, your x's, your x squareds, except now we'll keep our numbers separate. Okay, and we'll also keep the imaginary part separate. Okay, so we will add our numbers together, so we have -3 plus 4. Okay, and then we have -2i minus 4i. Okay, so when we finish this up, this is just 1 minus 6i. Okay, so adding, subtracting them, fairly simple, just we want to go back to collecting like terms. Okay, for this one here, we got -3. Okay, don't forget to distribute in this negative sign here. But we have -3 minus 4. Okay, and then we have -2i plus I. Okay, just because we have a negative and a negative here. Okay, so simplifying, we're left with -7 minus I. Okay, so adding and subtracting. Okay, pretty simple. We just stick to collecting like terms. Okay, multiplying them, okay, is the same as multiplying a binomial, so we're going to use FOIL. Okay, so first we do -3 times 4, so we have -12. Okay, then we do our outer terms, so -3 and I, so we have a positive 3i. Okay, negative 2 times 4 is negative 8i. And then we're left with the last one here, which is negative 2i minus I, so it's a positive 2i squared. Okay, so now we have to simplify. Okay, first, we know that I squared equals negative 1. Okay, so I'll just rewrite this. We have negative 12. I'll combine these two together. Just collect them, so we have a negative 5i. Okay, so then here we have a positive 2, and we're going to substitute in negative 1 for I squared. So we have 2 times negative 1, just minus 2. Okay, so now we can just finish it off. We would have minus 14 minus 5i. Okay, so our answers to these things, we never want to be left with I squareds or I cubed or I to the 4. We always want to reduce till we get either just regular numbers or just i's. Okay, let's look at some more examples. Okay, here we're going to divide complex numbers. Okay, so if we note here, okay, we have this thing called the conjugate. Okay, and all we're going to do when we divide complex numbers, okay, is we take the denominator or the bottom and we multiply the top and bottom by the conjugate of that. Okay, so right here I have negative 3 minus 2i divided by 4 minus I. Okay, what I'm going to do is I'm going to multiply top and bottom by the conjugate of the bottom. Okay, so all I'm going to do to get the conjugate is just flip the sign in the middle. So 4 plus I. Okay, and now I have two separate foils to do. So I'm going to FOIL out the top, FOIL out the bottom. Okay, when I FOIL the top, I get minus 12 minus 3i minus 8i minus 2i squared. Okay, when I FOIL out the bottom, I get 16 plus 4i minus 4i minus I squared. Okay, now again, notice I don't want these anymore, so I'll substitute in negative 1 for those I squareds. Okay, so when I simplify the top, I get negative 12 minus 11i plus 2, which is just negative 2 times negative 1. And on the bottom, I got 16 plus 1. Okay, so I'm just left with negative 10 minus 11i all over 17. Okay, so we're just breaking it up into two different foils here, sorry. Okay, so we'll FOIL the top, FOIL the bottom, and then we just do them out separately. Okay, if there was anything to reduce at our final step here, I could go ahead and reduce it, but this one doesn't work out like that, so there's nothing left to do. Okay, this example here, in the complex number system, which of the following is equal to 1 plus I over 1 minus I? Okay, so we'll go ahead and do that. Again, we're dividing here. So again, I want to multiply top and bottom by the conjugate of the bottom. The conjugate of the bottom is 1 plus I. And now again, FOIL the top, FOIL the bottom separately. So when I FOIL the top, I get 1 plus I plus I squared. And for all the bottom, I got 1 plus I minus I squared. Now again, I squared equals -1. So I'll simplify again. 1 plus 2I minus 1 over 1. Plus and minus cancel each other out. And I have a minus 1, so I got 1 plus 1. Okay, so again, simplifying, one more step. 1 minus 1 is 0, so I'm just left with 2I over 2. Just left with I. Okay, so this is all they will ask us about complex numbers. Is either you have to add, subtract, multiply, or divide them. So if you're familiar with doing these, just treat them as foiling, and replace any I squared with a -1. Okay, so now we'll get into a bit of the geometry in this section. Okay, so the parallel lines and properties. So these are all properties that we're familiar with. Okay, the biggest thing is note that these two lines are parallel. Okay, they tell us they're parallel with these arrows right here. Okay, but for these properties to work, they have to be dealing with parallel lines. Okay, so a Z pattern, okay, simply in the shape of a Z, the two inside angles become equal to each other. So in this case, angle 4 equals angle 8. Okay, now any of these we can flip upside down, we can flip side to side, it doesn't matter. Okay, so this right here, the blue, is also a Z pattern. It's a little bit harder to see. Okay, but this would tell us that angle 5 and angle 1 are the same. Okay, the F pattern is just the shape of an F. Okay, and the bottom parts of these are the same. So in the F pattern, angle 3 would equal angle 5. Okay, right here, the orange one, I have a backwards F. And it tells me angle 2 equals angle 8. Again, the bottom part of the F. Okay, I can also flip these upside down. Again, the bottom part, angle 1 equals angle 7. And then angle 4 equals angle 6. 4 equals 6. Okay, the C patterns are a little bit different. Okay, in the C pattern, what it says that the two inside angles of the C, they add up to 180. Okay, so here angle 4 plus angle 5 would equal 180. Okay, which makes sense. They're just supplementary angles because we know that 4 and 6 are the same. Okay, if 4 and 6 are the same, this is a straight line, so they're supplementary angles, so angle 5 plus angle 6 would also equal 180. Okay, and the last one we want to be familiar with is the opposite angle theorem, which just means the angles across from each other. So angle 5 equals angle 7. Okay, angle 2 equals angle 4. Obviously 6 and 8 would be the same, 1 and 3 would be the same. Okay, so pretty simple, but they will help us out when we have a more complex problem. Okay, just a quick review on triangles. Okay, if we're talking about this angle here, adjacent means the angle right next to it, opposite means the angle across from it, and then the hypotenuse is always opposite the 90. Okay, so the hypotenuse is always the longest side. Okay, so if we wanted to solve for any of these values, okay, we could use SOHCAHTOA. Okay, so SOHCAHTOA means the sine, in this case of angle A, equals opposite over hypotenuse. Okay, cos means the cos of any angle equals the adjacent side over the hypotenuse, and the tan of any angle equals the opposite over the adjacent. Okay, so real quick reminder, we only use SOHCAHTOA though when we're dealing with 90-degree triangles. Okay, if it's not 90 degrees, we can't use SOHCAHTOA anymore. Okay, and then the Pythagorean theorem. Okay, again for right angle triangles, so for 90-degree triangles. Okay, all it is a squared plus b squared equals c squared. Okay, so the sum of the two smaller sides squared equals the hypotenuse squared. Okay, so we can always use this to help us solve triangles, but again, something we're all familiar with. Okay, just as something that might save you some time if you can recognize it. Okay, is they have these right triangles. Okay, if they have the side lengths of say 3, 4, okay, the way it works out is that the hypotenuse would always be 5. Okay, and these can also be any multiple. Okay, so if we doubled each side, 6, 8, and 10, that would also work. Okay, so it can help save us some time. Okay, if we're trying to find one of those side lengths, if we can recognize this, say they gave us this 5, this and 4. Okay, we notice that this is one of those nice triangles that works out. I know without even doing any math that I can make this one 3. Okay, another one like that is 5, 12, and 13. Okay, or any multiple of that. So it could be 10, 24, 26. Okay, if you can't recognize them, it's not a big deal. Don't worry about it. You just have to do a quick Pythagorean theorem, but if you can see it, just save you a couple seconds. Okay, so some SOHCAHTOA problems here. Okay, in a right triangle, one angle measures x degrees, where the sine of x is 4 over 5. So what is the cos of 90 degrees minus x degrees? Okay, so it sounds fairly complicated, but all I want to do is if I can set up a triangle, help give me a visual. Okay, I'll say this is x. Okay, sine again is opposite over hypotenuse. Okay, so the opposite here is 4. The hypotenuse here is 5. Okay, from those triples that work out, I can assign this to be 3 just in case I need it. Okay, but now what they're asking for is what is 90 minus x? The cos of 90 minus x. Well, here's my 90. Okay, here's x degrees. I know that this angle here is 90 minus x. Okay, so now I'm just looking for the cos of this angle. Okay, the cos of 90 minus x equals cos again. Ka is A over H, so adjacent over hypotenuse. Adjacent to this is right next door, so again it's 4, hypotenuse is still 5. So it represents the same thing. Okay. So in the triangle above, the sine of x degrees is 0.6. What is the cosine of y? Okay, so this is almost the exact same question here. Okay, the sine of this angle and the cos of this angle are going to end up giving us the same thing. Okay, but just to recognize it, I'll go through it again. So sine x degrees equals 0.6. Okay, 0.6 I can write as 3 over 5 just to help me give me side lengths, which is the opposite over hypotenuse. So sine of x, the opposite is 3, hypotenuse is 5. Okay, so now if I go to the cos of y, adjacent over hypotenuse, the adjacent side to this angle is again 3, hypotenuse is still 5. So it's still the same thing, 0.6. Okay. So similar triangles. Okay, there are 2 or more triangles that have the same shape. Okay, if they have the same shape, that means all their respective angles are the same. Okay, but they'll have different side lengths. So just think of it as you're just taking a triangle and you're shrinking it. Okay, the angles are staying the same, but the side lengths are going to change. Okay, so when triangles are similar, their corresponding side lengths share the same ratio. Okay, one thing to note here is always make sure the triangles are in the same orientation. Okay, so if I wanted to put these triangles in the same orientation, let's say this is A, this is B, this is C. Okay, I have to match up the angles that are the same. Okay, so the long side here, this would be B. In this triangle, this would be A, and this would be C. Okay, just imagine that I'm just tipping this over so that my hypotenuse is across from everything else. Okay, so this question here, a summer camp counselor wants to find length x in feet across a lake as represented in the sketch above. Okay, the lengths represented by AB, EB, BD, and CD on the sketch were determined to be 1,800 feet, 1,400 feet, 700 feet, and 800 feet respectively. Segments AC and DE intersect at B, and angle AEB and CDB have the same measure. What is the value of x? Okay, so it's kind of a long-winded question. It gives us all this information. Okay, but first thing we want to do is we want to label our triangles. So AB is 1,800. Okay. EB is 1,400. Okay, BD is 700. And CD is 800. Okay, now what else do I know about this? I know that this angle and this angle are the same. Okay, and then they also tell me that this angle and this angle are the same. Okay, which leaves me with this angle and this angle are the same. Okay, so I do have 2 similar triangles here. Okay, I have similar triangles, so again, my side lengths are going to share the same ratio. Okay, so if I were to flip B, D, and C over, okay, or rotate it, okay, I know that BD is the same as BE, okay, and I also know that DC is the same as AE. Okay, so I'm going to use the fact that they have the same ratio to determine this final measurement here. Okay, so if, what is it here? BE and BD have the same ratio. Okay, that's 1400 over 700. I know that has to equal X over 800. Okay, now I can either do this intuitively or I could math this whole thing out. Okay, but I noticed that 700 is half of 1400. Okay, so I know that 800 would have to be half of what was ever on top here. Okay, which would leave me with 1600. Okay. Or if I wasn't comfortable doing it that way, I could just math this out, multiply this side by 800, also multiply this out by 800. Okay, and I'd be left with the same thing. So if I were to do the math over here, I would have 800 times 1400 divided by 700, and I'd still be left with 1600. Okay? Okay, so the next example here. Okay, in the figure above, PQR, okay, is similar to XYZ. Okay, with vertices PQR corresponding to XYZ. So that's just telling me it's in the right orientation. If the cos of R equals 0.263, what is the value of cos of Z? Okay, all this question is asking is that you recognize that cos of R, okay, is 0.263, so all that is just that is just a fraction, okay, but it's just saying it's the adjacent over hypotenuse, okay, and I know that cos of Z is also the adjacent over the hypotenuse, and their side lengths are just ratio of each other. So all it's trying to show you is that all cos of Z would be the same fraction, just expanded. Okay, just a bigger fraction. So instead of being, say, 1 over 2, it was 2 over 4. Okay, but it's the same thing. So the cos of Z is still 0.263. Okay, so if all the side lengths have the same ratio, okay, then their corresponding SOHCAHTOA would be the same thing. Okay, so the sine of P over here is the same as sine of X. Okay. So in the figure above, lines L and M are parallel, and lines S and T are parallel. Okay, if the measure of angle 1 is 35, okay, what is the measure of angle 2? Okay, now there are a whole bunch of ways you can get there. You can use Z pattern, F pattern, it doesn't matter what you use. Okay, but what we have to do, okay, is just somehow relate this angle to angle 1 to angle 2. Okay, so what I'll do is I will use 2 F patterns. Okay, I'll use 1 F pattern here, so I know this angle must also be 35. Okay, and then I'll use another F pattern here. So I know that this angle is also 35. Okay, I'll rewrite that. So this is 35. This is 35. Okay, and then I'm just left with supplementary angles here. So 180 minus 35 equals 145. So D is my final answer. Okay, there's a whole bunch of ways to get to that angle. Okay, whatever you see best. If you see Z patterns better, then use Z patterns. Doesn't really matter what you use. Okay. Okay, now we'll deal with circles. Okay, so first we got to know that the number of degrees that make up a circle is 360, which makes sense. It's just one full rotation. Okay. Now the first thing they may ask us to find is the length of an arc of a circle. So all an arc is a portion of the circumference. Okay. Again, we find the arc length by taking the angle, dividing it by 360 because it's a portion of the entire circle, okay, and then just multiplying it by 2 pi r, which is just the circumference. Okay, so what doing the angle divided by 360 is that will give us just a percentage of the entire circle. Okay, so circles can also be measured in radians as well as degrees. Okay, what it says is that there are 2 pi radians in a circle. Okay, so it follows that 2 pi must equal 360 degrees. Okay, and just pi equals 180 degrees. Okay, so this picture here is telling us that this is just converting all of the degrees into radians. Okay, one way to do this though, okay, is if I'm looking, say I'm trying to convert 60 degrees into radians. Okay, I just want to take 180. Okay, because that's how many radians are in degrees. Okay, and to get it to 60, I know I have to divide it by 3, would give me 60. Okay, so now I'll just replace 180 with pi, and I'll still divide it by 3. Okay, so these two things here are equivalent. Okay, and I can do that for any one of these. Okay, so in the above circle, the angle A is pi over 4. So what is the length of the arc A? So it's asking me what is the length of this right here. Okay, so probably the easiest way to do this is we can just change this into degrees. So this is 180 over 4, okay, which is equal to 45 degrees. Okay, and then we will use our arc length formula here to determine what percentage 45 degrees is of 360. So I know that my arc length, now let's erase this. Okay, I know that arc length equals whatever my degrees are divided by 360. Okay, times 2 pi r. Okay, so this equals 45 over 360 times 2 pi r. Okay, so 45 over 360 I can reduce to 1 over 8. and again times 2 pi r. Okay, it doesn't tell me what 2 pi r is. It doesn't tell me what r is. I have no way of finding out. Okay, so this is just 2 pi r over 8. Okay, sorry, I can just reduce to pi times r over 4. Okay, there's nothing more I can do here, so I'm done. Okay, some special things to know about the angles in a circle. Okay, so we have things here called inscribed angles, okay, which just means that when we connect 3 points that lie on the circumference of the circle, okay, what happens here is if this 82 means that if it connected to the radius, okay, all angle x here would be half of 82. Okay, so angle x here would be 41 degrees. Okay. So these are all fairly simple theorems, but we just have to make sure that we're familiar with them. Okay, so inscribed angles that intersect. So right here, A, B, and C intersects with ADB. Okay, I just know that angle C is the same as angle D. Okay, they share this arc right here, so both of these would be half of this arc. Okay, here the final theorem. Okay, our tangents. Oops, sorry. Okay, what tangents are is just if a tangent of a circle connects to the radius, okay, we just know that it's a 90-degree angle. Okay, all a tangent is oh, that's a terrible drawing. Okay, a tangent of a circle just connects at one point to the circumference. Okay, and any point that connects a tangent to the radius meets at a 90-degree angle. Okay, also on the circle there's just some different parts of the circle. Okay, just a refresher, diameter goes from one point on the circumference through the center to the other side. Okay, remember that diameter is 2 times r. Okay, and the radius just connects center of a circle to the edge. Okay, and then the last one is just what they call a chord. A chord connects any 2 points that are on the outside of the circle. Okay, so here's 3 examples of kind of the stuff we just talked about. So in the first one here, in the figure above, okay, triangle ABC is inscribed in the circle with center 0 and diameter AC. Okay, if AB equals AO, what is the measure of ABO? Okay. So again, they're kind of giving us some info that we don't necessarily need. Okay, I know that O is the center of the circle. A is a point on the edge, so AO is the radius. Okay. They tell me that AB equals AO. Okay, so that this length is also a radius. Okay, and I can tell from the picture that OB is also a radius. Okay, so what I have here is this is radius, radius, radius. Okay, this is just an equilateral triangle. Okay, equilateral triangles all have the same angles. Okay, which is just 180 divided by 3, 60 degrees. Okay, so D is my right answer here. Okay, so the next question here. Point O is the center of both circles in the figure above. Okay, if the circumference of the large circle is 36 and the radius of the small circle is half the radius of the large circle, what is the length of the darkened arc? Okay, so I want to know at the end what this length is. Okay, but first I want to try and find the values of this radius. Okay, so in the first case, okay, I know that circumference equals 2 pi r. Okay, so of my big circle, I have 2 pi r. Okay, now I can either divide by 2 pi, or I just divide it by 2. If I divide it by 2, it's just knowing that because pi will be in my smaller circle too, I don't really have to eliminate that, but just for the simplest way to do this is to divide by 2 pi. Okay, so we're also dividing this by 2 pi. Okay, so what I'm left with is the radius of this circle the radius of the big circle is 5.73. Okay, so if that's the radius of my big circle, then it follows that the radius of my smaller circle, okay, is just 5.73 divided by 2, because it's half the size, equals 2.86. Okay, so I'm going to take 2.86 now. I want to find the circumference of the smaller circle. Okay, so it's 2 pi times 2.86. And it just gives me 18. Okay, so I did all that work. Okay, it was a little bit unnecessary, okay, just because the circumference of the big circle was 36, circumference of the little was 18. Okay, 18 is just half of 36 because the radius was half. Okay, so I did it the long way, but just to see you where it was coming from. If you can't recognize that, then just do it the way I just did it. Just divide out the numbers that you know, okay, and you'll be left with some decimals. Okay, so if the circumference of the little one is 18, okay, my arc length, okay, equals 80 over 360 times 18. Okay, 80 over 360 gives me 0.2222. Just multiply that by 18. Okay, and it just gives me 4. Okay. So I had to find some things by myself, like find the radius of the circles. Okay, but once I find it, I'm just going to again plug into the arc length equation. Okay, if I were to become very familiar with this equation, okay, it will come up for sure on the test. Okay, in the figure above, 0 is the center of a circle. Okay, BC is tangent to the circle. and A lies on line segment OC. Okay, if OB equals AC, which is both 6, what is the area of the shaded region? Okay, so the area of the shaded region. Okay, what I want to do, okay, there's a few different parts to this question. Okay, but if we just want to break it up into what we know. Okay, so first thing I should notice is the rest of the circle, okay, doesn't concern me. Okay, I'm only going to deal with just the part of the circle that intersects with the triangle. Okay, that's the first thing I want to know. Okay, the second thing I can see is that, okay, OB is 6. Okay, that's the radius of the circle. Okay, OA is also the radius of the circle, so that's 6. And it tells me AC is 6. Okay, another thing to notice, okay, is that BC is tangent. Okay, and I see that it runs through the center, so I know that this is 90 degrees. Okay, so I'll simplify that and draw it out. So I have here, here, and here. Okay, this is 12. Okay, this is 6. And this is 90 degrees. Okay, so first thing I need to do is find this unknown side. We'll call it x. Okay, I'll just use Pythagorean theorem to do that. Okay, so I'll have x squared plus 6 squared equals 12 squared. Okay, x squared equals 144 minus 36. X squared equals 108. X equals the square root of 108. Okay, so that's the first thing that I want to find. We got 6, we got 12, we got square root of 108. Okay, now the square root of 108. Okay, I want to simplify. Okay, if we're not familiar with simplifying radicals, okay, what I want to do is separate the term into the highest perfect square I can find. Okay, so 36 times 3 equals 108, and 36 is the highest perfect square that'll divide evenly into 108. Okay, so what I mean by perfect squares is like 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, what else I got here, 64, 81, and 100. Okay, so 36 is the highest number that divides nicely into 108, so I separate 108 into 36 times 3, okay, which is 6 root 3. Okay, so first what I want to do is I need two different areas here. I need the area of that segment of the circle, and I need the area of the triangle. Okay, so the area of the triangle is 1/2 base times height, which is 1/2. In this case, the base is 6√3, and the height is 6. Okay, so this, when I do this out, it'll give me 36√3 over 2. Okay, I just multiplied 6 times 6 to get my 36 right here. Okay, it leaves me with 18√3. Okay, so that's the area of my triangle. Okay, so area of the triangle was 18√3. Okay, now the area of the circle is pi r squared. R is 36, so it's 36 pi. Okay, but notice I'm only dealing with a certain portion of this circle. Okay, now the portion of that circle I'm dealing with, okay, is, again, what I can do is I can recognize, okay, two things about this circle. Oh, that's a terrible circle. Okay, or actually two things about the triangle, I guess. Okay, here's my triangle. Again, I know this is 90. I need to find what this angle is. Okay, this falls in actually a special property. Okay, but recognizing that can be difficult, but what I can do is I'll just take the sine of this angle. Okay, we'll call it the sine of O. Okay, it equals opposite over the hypotenuse. Okay, or I could do cos, it doesn't matter what I do. Okay, but it's 6√3 is the opposite, hypotenuse is 12. Okay, so O, let me erase this actually. Okay, so the sine of O is opposite over hypotenuse, so again it's 6√3 over 12. Okay, so O is the inverse sine of 6√3 over 12. Okay, when I do this, I'm going to be left with 60 degrees. Okay, so if this is 60 degrees, again, just like I found the arc length, that now I want to find what portion of the area 60 degrees represents. So the portion of the area is just, it's 60 degrees of 360. Okay, and now I'll just multiply, instead of multiplying by the circumference, I'll multiply by the area. So this is 1 over 6 times 36 pi, okay, which gives me 6 pi. Okay, so the area of the circle is 6 pi. Okay, and now I'll find the area of the shaded region by doing area of the triangle minus the area of the circle. Okay, which equals 18√3 minus 6 pi, which is B. Okay, again, a challenging question, took a lot of time. Okay, but if you can, again, if you have time to answer that question, okay, go back and do it. Okay, I wouldn't suggest doing that question the first time through the test. Okay, unless you're able to just fly through very quickly. Okay, so now we'll get into the formula of a circle. Okay, it takes this formula right here. Okay, x minus h squared plus y minus k squared, and it equals the radius squared. Okay, so one thing to notice here is, again, because our initial formula is minus h and minus k, okay, when I'm finding the actual center of the circle, okay, I'll take away that negative. Okay, so basically the center of the circle will be the opposite sign of what's in front here. Okay, that's why here we're at positive h and positive k. Okay, so if I were to draw this circle here, so I have x squared plus y squared equals 9. Okay, same thing as writing x minus 0 squared plus y minus 0 squared equals 9. Okay, so the center of my circle is simply 0, 0. Okay, 9 r squared equals 9, which means my radius is just 3. Okay, so if I were to draw this, my radius, all these are just 3. My circle looks like that. Okay, the red one here. Okay, the center of this circle, again, I want to flip whatever's in front here. So this is positive 2 and negative 4. Okay, and my radius here is 16. My radius squared is 16, so my radius is just 4. Okay, so 1, 2, 1, 2, 3. Here's the center, and a radius of 4. So 1, 2, 3, 4, 4. Okay, so here's my circle. Okay, when you're counting the radius, it's easiest just to go completely horizontal, completely vertical. Okay, and then just connect. Okay, you won't be asked to graph one, but just so that you can see the visualization of what the circle looks like. Okay, now we will have to manipulate equations of our circle. Okay, and solve for whatever we're looking for. They might ask us for the center of it, they might ask us for the radius of it, whatever the case. Okay, now the graph of the equation above is a circle. Okay, and then they're asking for the radius of the circle. Okay, so this is a tricky question, especially if you've never completed the square before in a quadratic. Okay, but we're going to use that principle. Okay, so the first thing is I'm just going to deal with my x's first. Okay, notice that x squared plus 8x, okay, is not in the form that I want it to be in. Okay, I want this to look something like x minus something squared. Okay, so to do that, okay, I have to complete the square of what they gave me, of what they started me with. Okay, so to do that, okay, I'll rewrite what they give me. Okay, and now I'll take 8x, or just 8 really, is all I'm dealing with. Okay, but I will divide that by 2, okay, which will give me 4, and then I'm going to square it, which will give me 16. Okay, so again, to complete the square, like this is a tricky question, but to complete the square, I'm going to take 8x divided by 2. 8 divided by 2 is 4, and then I'm going to square that, which is 16. Okay, so what I do now is I'm now going to add 16, and I'm going to subtract 16. Okay, I have to add it first because now I'm only dealing with this portion of it. Okay, so what you just did for yourself, okay, is that you just made this now x plus 4 squared. Okay, if I were to FOIL this out, I would be left with x squared plus 8x plus 16. Okay, but a cheat is, okay, just take their middle term, divide it by 2, and that's what you're going to put. Okay, so again, I haven't dealt with this minus 16 yet, okay, but I will in a second. Okay, now, second part of this is now I'll do the same thing with the y's. Okay, so I have y squared minus 6y. Take the minus 6, divide it by 2, which is negative 3, and I'll square it. Okay, so again, I will do plus 9 minus 9. Okay, so I have y squared minus 6y plus 9 minus 9. Again, I'm only going to deal with the plus 1. Okay, so again, what I did is I made another perfect square, and this one is just y minus 3 squared. But I still have this minus 9 to deal with. Okay, and this whole thing equals 24. So x plus 4 squared plus y minus 3 squared. Now I'm going to move the 16 and the 9 over. So I'm 24. Okay, I got to do plus 16 plus 9. Okay, so this equals 49. Okay, so my final equation is x plus 4 squared plus y minus 3 squared equals 49. Okay, so the radius of the circle, I know that r squared equals 49. Okay, when I square root that, r just equals 7. So the radius of my circle is 7. Okay, just for your knowledge, also the center of the circle would be minus 4, positive 3. Okay, so by completing the square, we get into the form that we want to be in. Okay, so the graph of the equation above in the xy plane is a circle. If the center of the circle is translated 1 unit up and the radius is increased by 1, which of the following is an equation of the resulting circle? Okay, so first, I can get a visual of what's going on here just by plotting where this circle is. So, again, the center of this is 0, minus 1. Okay, so here's the center of my circle. Okay, my radius here is 2. Again, r squared equals 4. So radius is just 2. So I look like this in general. Okay, and what this question is asking me is to translate it 1 unit up, okay, and increase the radius by 1. So if I move this 1 unit up, okay, it would get me right back to the origin. Okay, so the center of my circle is now 0, 0. Okay, my radius was 2, okay, but it's asking me to increase it by 1. So now my radius equals 3. Okay, so now I have the center, I have the radius, and I just want to plug into the equation of the circle. So the equation of the circle is, again, x minus h squared plus y minus k squared equals r squared. Okay, so let's plug in what I know. H is 0, k is 0, radius is now 3. Okay, so these don't matter anymore. I'm just left with x squared plus y squared equals 3 squared, which is 9. Okay, so B. Okay, so next question here. Which of the following is an equation of a circle in the xy plane with the center of 0, 4 and a radius with endpoint 4/3 and 5? Okay, so the first portion of this question. So with a center of 0, 4, okay, I know that I have x squared. I have to flip the sign, so I'm y minus 4 squared, then it equals radius squared. Okay, so immediately, because I have to flip this, okay, it becomes minus 4, so I can eliminate here, I can eliminate B and D. Okay, but now let's find what the radius is. Okay, so this can be, again, a little bit tricky. Okay, but, okay, 0, 4. Okay, and I know my radius is somewhere here. Actually, let me redraw this here. Here's 4. Okay, and here we'll say is 4/3 and 5. Okay, so what I'm going to do here is my circle is looking something like this. Okay, where here is the radius. Okay, now, okay, what I need to do to find this radius is make this into a triangle. Okay. Okay. I'm going to separate it into a triangle, and I'm going to worry about my x coordinates and my y coordinates. Okay, so my x coordinates here, I have 4/3, okay, and I also have 0. Okay, so this x will be 4/3 minus 0. Okay, so my x coordinate is just 4/3. Okay, now my y coordinates, okay, I have, here's my y, I have 5 and I have 4. Okay, so my y coordinate here is 5 minus 4. Okay, so what I just made was a triangle. This is the radius. Okay, this is the y coordinate, which is 1. This is the x coordinate, which is 4/3. Okay, so I just made a right angle triangle. Okay, and now I can find the radius. Okay, so my radius squared equals 1 squared plus 4 over 3 squared, which equals 1 plus 16 over 9. Okay, common denominator, 9 over 9 plus 16 over 9 equals 25 over 9. Okay, now the final equation of a circle is already represented as r squared. Okay, r squared is 25 over 9, so A is my correct answer here. Okay, so I had to do a little bit of extra work there to find the radius. Okay, but all I want to do is separate it into x coordinates and y coordinates. Okay, the circle above has an area of 25 pi. Okay, so right away I'll write that down. So 25 pi equals pi r squared, and is divided into 8 congruent regions. Okay, congruent just means they're the same. What is the perimeter of one of these regions? So, okay, what this tells me here, okay, is 25 pi equals pi r squared. Okay, if I divide both sides by pi, okay, I'm just left with r squared equals 25, which tells me that the radius of this circle is 5. Okay, so this is 5. Okay, so I want to find the perimeter of these regions. Okay, the perimeter of a circle, we don't call it perimeter, we call it circumference. Okay, so now what I want to do is find the circumference of this whole circle. Okay, circumference of a circle equals 2 pi r. Okay, so the circumference of this circle is just 10 pi. Okay, so now I'm just going to combine everything that I know now. Okay, my radius is 5. Okay, the circumference of the whole circle is 10 pi. Okay, so if I'm looking at this circle, okay, radius is 5. This radius is also 5. Okay, now I just need to find this portion of the circumference, okay, which is an arc length. Okay, so again, I'm going to go back to that formula. Okay, so arc length equals, okay, the amount of my circle normally divided by 360, but now I just know that each portion of this circle is 1 over 8 because it's divided into 8 parts. Okay, times the circumference, it's 10 pi, is just 10 pi over 8, which I can reduce to 5 pi over 4. Okay, so my arc length is 5 pi over 4. Okay, so now when I add them all together, I have 5 plus my arc length. Okay, so the perimeter equals 5 plus 5 plus 5 pi over 4, which is just 10 plus 5 pi over 4. Okay, so volume and area. Now the last thing we'll talk about here, okay, they're going to give us the equations that we need. Okay, a lot of times though we'll have to combine them together, either by adding them together, subtracting them, whatever the case is. Okay, because they'll give us what they call composite shapes, which is just two or more shapes that make up a new one. Okay, so this question here, okay, a glass vase is in the shape of a rectangular prism with a square base. Okay, the figure above shows the vase or vase? I'm going to say vase. Okay, shows the vase with a portion cut out to show the interior dimensions. Okay, the external dimensions of the vase are 5 inches, a height of 5 inches, square base that are each 2 by 2. Okay, the vase has a solid base of height 1 inch, and the sides are each a quarter inch thick. Which of the following is the volume in cubic inches of the glass used? Okay, so the glass used, I want to find my final area. Okay, is going to be the area of the outside subtracted by the area of the inside. Okay, so I'm going to find these separately and then subtract them from each other. So the area of the outside, area of a rectangular prism is length times width times height. Okay, my length and width in this case are both 2 because they tell me it's a square. And my height is, what they say, 5. Okay, so that just equals 20. Okay, if I'm being 20 inches squared. Okay, the area of the inside now, okay, is a little bit trickier. Okay, notice that each of these are a quarter inch. Okay, so the area of the inside here is 2, okay, minus a quarter inch on each side. Okay, which at the end will just give me 1.5. Okay, so the area of the inside is again length times width times height. My length and width are 1.5. Okay, and my height here, it was 5, but now they tell me I'm taking away an inch, so my height is 4. Okay, when I multiply this out, it'll give me 9 inches squared. Or sorry, inches cubed. This is cubed, it's volume. Okay, I found area of the outside, I found area of the inside. Okay, my total area now is just 20 minus 9 equals 11. Okay, so just be careful here. If they tell you that it's a quarter inch smaller, we have a quarter inch over here and a quarter inch over here to account for. Okay, so that's one thing that can be tricky. Okay, so a dairy farmer uses a storage silo that is in the shape of a right circular cylinder. Okay, if the volume of the silo is 72 cubic yards, what is the diameter of the base? Okay, so we need the volume of a cylinder. Okay, again, if we scroll all the way back to our original, to the very start, okay, they give us all of these equations that we need. Okay, so the one we need in this case is the volume here is pi r squared times h. Okay, so first plug in what I know. So I know 72 pi is the volume. and I know that it equals pi r squared, and they give me h. Okay, so my first move, I will just divide out by 8. Divide both sides by 8. This leaves me with 9 pi equals pi r squared. Okay, the pi's will cancel each other out. Just left with r squared equals 9. This tells me r equals 3. Okay, now, hint here is the underlined diameter. Okay, because a lot of times people will arrive at this answer and just say 3. Okay, I know that diameter equals twice the radius, so diameter here just equals 6. Okay, this is radius, the whole thing is diameter. Okay, so the diameter is just 6 here. Okay, so a sphere of radius r inside a cube touches each one of the 6 sides of the cube. What is the volume of the cube? Okay, so a sphere inside a cube. Okay, so I'm going to draw it in 2 dimensions. Okay, so a sphere inside a cube. So I look like this. Okay, it tells me it has a radius of r. Okay, and I want to know the volume of the cube. Okay, so the volume of a cube is again length, width times height. Okay, and in this case they're all the same. Okay, so this whole length here though, okay, is r, and we have another r on the other side. So our whole length is 2r. Okay, so we're just 2r, 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 just left with 8r cubed. Okay, so they're asking this question even though they're talking in 3 dimensions. Okay, all we're trying to find is the side length of the cube. Okay, so I can draw it in 2 dimensions and then just adapt it. Okay, and the last question here. Okay, the height of a right cylinder is 5 and the diameter of its base is 4. What is the distance from the center of one base to a point on the circumference of the other base? Okay, so again, I want to draw what this picture is saying. Okay, so I'm going to draw my cylinder. Okay, I know that the height is 5. Okay, I know that the diameter is 4, which will give me a radius of 2. Okay, and what they're asking is go from the center, okay, to the edge of their circumference. Okay, so what I just did here was I just created a right angle triangle. Okay, if I look at my triangle, it's 2, it's 5. I need to find the hypotenuse. Okay, I'll call it x. So x squared equals 5 squared plus 2 squared. 25 plus 4 is equals 29. Okay, just square root both sides. X equals the square root of 29. Okay, so this example, they're giving us a whole lot of information. Okay, and we just have to adapt to what I know. Okay, a lot of times they will give us diameter and ask us for radius, or they'll do the opposite. Okay, so just keep that in mind. Okay, so that is all that question is asking us. So the correct answer here is C. Okay, here again are practice questions. Okay, some sample questions right from the College Board. Okay, try those out, and again we'll go through some practice tests on Tuesday. Okay.